In note 6.4, example 10, we're given the equations of 8 sine or cosine graphs, and then we're given a bunch of graphs, and we're trying to match the equations to the graphs. In order to do this, we first have to understand the window. So here it's shown up here at the top. So the x minimum goes from, the x minimum value is negative 2 pi, and the maximum is 2 pi. That's the same for all these graphs. So I'll put it on letter A. So we have to remember the x scale. And the y values go from negative 5 to 5. So on all these graphs, each tick on the y-axis is 1 unit. All right, so let's begin. When I'm trying to do these problems, I'll try to identify key characteristics from the equations and find a graph that matches those equations. So for example, for number 1, we know we have an amplitude of 4 from the 4 in front of cosine x, and the b value is 2, so the period is 2 pi over 2, which is pi. So we're looking for a cosine graph with an amplitude of 4, a period of pi, and no vertical shift. So the midline is y equals 0, and cosine starts at a maximum. So we want this graph to be going through the point 0, 4. So when looking at the graphs, I have this, the letter A actually looks like a cosine. It goes through 0, 4. The amplitude is 4, but the period for this graph, I'm going to go from a maximum to the maximum, is 2 pi, and we're looking for a period of pi, so it's not graph 1. So if we scan through trying to find another one that looks like a cosine graph and has a midline, an axis of oscillation at y equals 0, and an amplitude of 4, the graph that we can find, I have to scroll down a little bit because I don't see it yet, is graph G. So let's confirm this. So 2 pi and pi, I'm putting on the x scale. So this graph has a period of pi. It goes through a maximum when x is 0, and the axis of oscillation is y equals 0, and the amplitude is 4. So number 1 corresponds with graph G. And I will cross off G. Next graph, we have 2 sine x plus 3. For this graph, the midline is at y equals 3 because it's shifted up 3 units. And the amplitude is 2. The period is unchanged, so the period is 2 pi. So I'm going to go through now, and I am going to sketch in the axis of oscillations for all the graphs that are not at y equals 0. That will help us as we go forward. So letter B has an axis of oscillation at y equals 1. Letter E also has a shift. Its axis of oscillation is at y equals 3. Letter F also has a shift up 1. Its axis of oscillation is at y equals 1. Letter H is also shifted up, so its axis of oscillation is at y equals 3. I'll put that on. And letter I is shifted. Let's see how far it's shifted. It's shifted down 1 unit. Okay, so that'll help us going forward. So now for number 2, we're looking for a graph that's a sine function. So if it's sine, it's going to go through the midline at x equals 0, and an axis of oscillation at y equals 3. So as I look through the graphs, I have 2 that have an axis of oscillation at y equals 3. Letter H is going through the midline, but the graph is going down, so that would be negative sine. So it's not going to be letter H. So let's check letter E. Letter E goes through the midline. It's going up, so it's a positive sign. The axis of oscillation is y equals 3, and the amplitude is 2. From the midline to the maximum is 2 units. So number 2 corresponds with E. Let's take a look at our next graph. 3 sine 4x. Okay, so this is a sine graph. The only thing that's changed here relative to the parent is the period. the period is going to be 2 pi over 4, which is pi over 2. Or remember, the b value tells you that there'll be 4 cycles in 2 pi. So we can look for a graph that has 4 cycles on the right half of our graph. The sine function is going to be going through the origin because there's no shift, and it's going to be going up. So as we scan through these graphs, let's see, C is a possibility. I think C is the only possibility. Let's make sure that it's correct though. So for letter C, it's a sine. It's going through the origin. It has an amplitude of 1. And the period, we can count how many cycles there are in from 0 to 2 pi. So in an interval of 2 pi. And this scale, remember, goes from 0 to 2 pi on the right half. So I'm going to count the cycles. So we have, starts at a midline, 1, 2, 3, 4. So this is the correct graph. So 3 is C. Alternatively, you could highlight one cycle and see how long it takes. So I'm going to highlight one cycle. So it starts at the midline, and then you have to have one part going up and one part going down. So that's one cycle. And that value on the x-axis is pi over 2. So the period is pi over 2. Number 4. Let's say what's happening in number 4. We have an amplitude of 3. Period is 2 pi over b, which is 2. So pi. And the midline is at y equals 1 because this is shifted up 1. So first I'm going to look for graphs that have a midline at y equals 1. So that is B or F. So that's what we're distinguishing between. We want a cosine function. So cosine is going to start at a maximum when x equals 0. B looks like a sine. So F looks like a cosine. The amplitude is at 3. Let's see, 1, 2, 3 from midline to the maximum because the maximum is at 4. So that looks good. And it is shifted up 1. The period should be pi. Let's verify the period. So this is one period from a maximum to a maximum. And then on the x-axis, this is 2 pi, and that's pi. So one cycle takes pi units. So number 4 is F. I'll cross off F and C. Okay, number 5 is a sine graph with an amplitude of 2. No vertical shift, so the midline is at y equals 0, but it's shifted right pi over 4. Okay, so I'm going to look for graphs that have an amplitude of 2. So let's see, which graphs have an amplitude of 2? So I have possibilities. D has an amplitude of 2. And which other options do we have? That H has an amplitude of 3. I has an amplitude of 2. So let's see, I'll write that down. This has amplitude of 2. And D has an amplitude of 2. Okay, so we want a sine function. So it should be going through the midline. But this is shifted right pi over 4. So it should go through the midline at pi over 4. So we're looking at I and D. I'm going to look at D first. So I'm going to put in my scale, 2 pi, pi over 2. So this graph is going through the midline at pi over 4. So that looks good. That looks like a sine graph with an amplitude of 2, shifted right pi over 4. So number 5 corresponds with graph D. I will cross off D. Okay, next one. We have a sine with an amplitude of 2 and a period of 2 pi divided by 1/2. B here is actually 1/2. So this is 4 pi. So the period is 4 pi and it's up 1. So first I'm going to look for graphs that have a midline at y equals 1. So graphs that have a midline at y equal 1 is F, which we already accounted for, and B. So let's consider B. Let's see if it works. The period, we want a sine graph, so it should be going through the midline. It's not reflected, so going up at x equals 0. So this corresponds, goes through the midline when x equals 0. The amplitude is 2, up 2 and down 2 from the midline. And the period is how long it takes for one full cycle. And this window goes from negative 2 pi to 2 pi, which is an interval of 4 pi. And that is one complete cycle. So number 6 is B. Okay, number 7, 2 cosine x minus 1. So this has an amplitude of 2. The period is unchanged, 2 pi, and a midline at y equals negative 1. So let's look for graphs that are left that have midlines at y equals negative 1. So I see I is left. Is that my only option? I think so. Let's make sure that I works. So we have a midline at y equals negative 1. And it should be, it's a cosine, so it should be going through a maximum when x equals 0. So this does go through the maximum when x equals 0. And the period is 2 pi. So number 7 corresponds with I. I'll cross off I. And now we're down to our last equation. So this is a sine graph with an amplitude of 4, left pi over 2. The period is still 2 pi. The axis of oscillation. The axis of oscillation is y equals 0. So we don't have that many graphs left. We need a sine graph which is shifted. So it should be going through the midline, pi over 2 units to the left of the origin. And we need an axis of oscillation of y equals 0. I think the only graph that's left with an axis of oscillation of y equals 0 is A. So let's make sure that A works. So it has an amplitude of 4. And it has a period of 2 pi and an axis of oscillation of y equals 0. And let's see where it crosses the axis of oscillation. So I'm going to put a few more units in here. So this is negative pi over 2. And this is supposed to be crossing at negative pi over 2, 0. And it is going up. It's a positive sine function. So 8 corresponds with graph A.